Hi, I'm Ms. Cho, and in this video we'll solve quadratic equations in vertex form. Let's take a look at an example. Here we have 2 times x minus 3 squared plus 5 is equal to 13. We know that if we want to solve this graphically, we can just set y equals the left side and y equals the right side and look for points of intersection. So I've done that in Desmos here. And we see we have a parabola and we have a line and we are looking for 2 points of intersection. How do we find them algebraically? To do that, we're going to reverse the order of operations. Let's take a look at y. When we start with an x, we can follow its journey and see it takes many steps to get to this final expression here. We start with an x, then we subtracted 3, then we squared it, then we multiplied by 2, then we added 5 to the whole thing, and we found that this was equal to 13. But I know that I can also reverse these arrows. It's like taking a train. If I go back uptown, I will pass through all the same stops, and I will eventually come back to where I started. So going downtown, we first had our operation in parentheses where we subtracted 3. And then we had our exponent where we squared, then we multiplied by 2, and then finally we added 5. To undo all of that and go back uptown, I can undo the plus 5 by subtracting 5. I undo the multiplying by 2 by dividing by 2. I undo a square by taking a square root, and I undo what was in the parentheses by adding 3. That will take me to this final value, which is the x that I started with. That gave me a 13. Let's follow our plan of action and find x by reversing the order of operations. So first we're going to subtract 5 from both sides. That leaves us with 2 times x minus 3 squared is equal to 8. Then we're going to undo our multiplication and division. I have multiplied by a 2 here, so I'm going to divide by 2. That leaves me with x minus 3 squared is equal to 4. Next, I'm going to undo my exponent by taking a square root. And the important thing is when you take a square root, you have to give a positive and a negative root. This leaves you with x minus 3 is equal to positive 2 and negative 2, because positive 2 times positive 2 is 4, negative 2 times negative 2 is 4. Because we have 2 possible answers here, which we saw in the graph, we're going to open up a t-chart and we're going to set the expression equal to the positive root, and we're going to set the left side equal to the negative root. From there, we finish our exponents, and then we can do our last step, undoing the parentheses, which in this case is adding 3 to both sides. By doing that, I have x equals 5 on the left, and when I add 3 here, I have x is equal to 1. Let's check our answer. To check, I'm going to go back and substitute in both values of x and see if it makes the equation true. So 2 times 1 minus 3 squared plus 5, I want to know if that's equal to 13. 1 minus 3 is negative 2, which I can recopy all the rest. Negative 2 squared is 4. And then 2 times 4 is 8. And 8 plus 5 is 13, so that checks out. The second value of x I'm going to check is 5. So here I'm going to sub in 5 for x and just recopy the rest of the equation. 5 minus 3 is 2. And then I'm just going to recopy everything else. 2 squared is 4. And then 2 times 4 is 8. And 8 plus 5 is 13. So 13 is equal to 13. This checks out. If we go back to our Desmos, we can see that yes, my first value is x value is 1, and my second x value is 5. So I know I've done it correctly. To recap, when you solve quadratic equations in vertex forms, you're going to reverse the order of operations to isolate y. Remember that when you take the square root, you will have both positive and negative roots. So then you're going to open up a t-chart and set your expression equal to the positive root and the negative root. You solve for x and you check your answer.